In the last class, we have introduced the language UML. So to recapitulate, the UML is a language for specifying, for visualizing, for constructing and documenting the artifacts of a software system. It can also be used for business modeling and other non-software systems. But it is important to know that UML is not a programming language, it is not a tool specification, and it is not a description of a software processes. The more specific aims of UML are as follows. UML is programming language independent. It is extensible around a well-defined core. It has a formal basis. It will be capable of supporting high-level concepts such as patterns, frameworks, etc. It can be recursively defined with a meta model. It can enable tool development. So we have looked at the basic components of the conceptual model of UML. It consists of three things. Number one, the basic building blocks. Number two, rules for putting these building blocks together, and some common mechanisms. The basic building blocks are: number one, things or the abstractions. Number two, relationships which tie these things together. Number three, diagrams that group interesting collections of things. And we have said that things are of four types: structural things, behavioral things, grouping things, annotational things. These structural things form the static part of the system, and there are 7 structural things: class, interface, collaboration, use case, active classes, components, and nodes. Behavioral things form the dynamic part of the UML model, and they represent behavior over time and space. There are 2 types of behavioral things: interactions and state machines. And grouping things put collections of things together. Package is the most important grouping things, and there are annotational things. For example, the note is the most important annotational things. Today, we will look at the relationships in UML and then go over to other portions. Relationships in the UML. There are 4 major kinds of relationships in the UML. Number one, dependency. A dependency is a semantic relation between 2 things. Dependency is a using relationship. It is a relationship between 2 things when a change to one thing affects another thing. A change to one thing affects the semantics of the other thing. And relationships are denoted in UML by arrow, a dotted arrow, from the independent thing to the dependent thing. For example, suppose a window is affected by an event. So there will be, in order to denote this in UML, there will be an arrow from the window object to the event object. The second type of relationship in UML is association relationship. So association is a structural relationship between sets of things. There are different types of association relation. One of the most important, an important association relationship that comes up often is the aggregation relationship or the whole part relationship. An association relationship is denoted by a solid line linking the two objects which are part of the association. And there are several ways this association relationship is labeled. For example, if this is an employer object and this is an employee object, this link is named by employer on this end and employee on this end, and we often also denote the multiplicity of the relationship. We also give this relationship a name. The third type of relationship is the generalization relationship. So this is a generalization specialization relationship which is denoted by a link from the child to the parent. Generalization is a relationship between the link from the child to the parent. The fourth type of relationship is the realization relationship. And realization relationship is a semantic relationship between classifiers. It is denoted in this way. Now, we will go to the diagrams in the UML. There are many important types of diagrams in UML, and they are one of the most important parts of the UML model. A diagram is a graphical representation of a set of elements. A diagram is important because through a diagram we can view a system from different perspectives, and there are different perspectives from which we can view the system. So we will talk about 9 different types of diagrams in UML. Number 1, class diagram. Class diagram shows a set of classes, interfaces, collaborations, and their relationships. They provide the static design view of the system. Number 2 is the object diagram. Object diagram shows a set of objects and their relationships. So they represent the static snapshots of the instances of the objects that are found in the class diagram. So object diagrams show the static design view from the perspective of prototypical or real objects. third, we have the use case diagram. A use case diagram shows a set of use cases. And actors and their relationships. They're important in organizing and modeling the behavior of a system. Next, we look at the fourth type of diagram, which is the sequence diagram. Sequence diagram is a type of interaction diagram. So sequence diagrams emphasize the ordering of the messages. Sequence diagrams is a type of interaction diagram that emphasize the time ordering of the messages. Fifth is the collaboration diagram. Collaboration diagram is also a type of interaction diagram, but collaboration diagrams emphasize the structural organization of the objects that send and receive messages. The sixth type of diagram is state chart diagram. A state chart diagram shows a state machine consisting of states, transitions, events, and activities. State chart diagrams model the dynamic view of the system. And they're important in modeling interface behavior, class, or collaboration. They emphasize the event-ordered view of an object. Next, we will look at activity diagrams. They show the flow of activity. They show the flow of the system from activity to activity. within a system. They are important in modeling the functional aspects of the system. And emphasize the flow of control between objects. The next type of diagram we will consider is component diagram. Component diagram shows the organization and dependencies among a set of components. A component typically maps to one or more classes, interfaces, or collaborations. The last type of diagram is the deployment diagram. It shows the configuration of runtime processing nodes and the components that live on them. Next, we have a brief look at the rules of UML. The building blocks of the UML cannot be simply thrown together. So what we really want to have is what is known as a well-formed model. A well-formed model is one that is semantically self-consistent, and in harmony with the related models. And the rules of UML are such that they encourage you but do not force you to form well-formed models. Rules of UML encourage you to address the most important analysis, design, and implementation questions that push such models to become well-formed over time. Now, on having looked at the components of the conceptual view of the UML, we will now go over to the modeling aspect of UML. There are three important modeling aspects: structural modeling, behavioral modeling, and architectural modeling. So today we will take up structural modeling, and we will first look at the basic structural modeling. As you know, classes are the most important building blocks of any object-oriented system. Let us have a look again at the simple class syntax. Before that, let us draw a representative class. This is a class account. Next, so if you recollect, we write classes in a rectangular box consisting of several compartments. The first compartment is the name of the class. So this is the class name compartment. Next, we have the attributes compartment, where we define the attributes of the class. For this class, the attributes are balance, which is of type money, and we have account holder, of type string, and interest rate of type integer. So this is the operation compartment. This is the attributes compartment. And the third compartment is the operations compartment. In this compartment, we define some of the important operations on the class. For example, for this class, we have the operation add interest, and we have another operation set overdraft level. So this is a simple syntax of a class. A class is a description of a set of objects that share the same attributes operations, relationships, and semantics. And a class implements one or more interfaces. All the classes, they model the vocabulary of the system. The vocabulary of the system mainly consists of two parts. One is the classes, they include the abstractions that are part of the problem domain, as well as there are classes that make up the implementation of the system. And modeling a system involves the identifying the things that make up a system. Identify the things that are in the vocabulary of the system. Then attributes are the named property of the class, and operations implement the services that are defined on the class and that can be requested from an object belonging to a class. Invoking an operation on an object may change the attributes of the objects. Now let us look at a little more detail into a class syntax, which is richer, where you put in a little bit more information. First, an example, the same example of the account. This hash sign before balance indicates that balance is a protected attribute. And when we write colon money, it means that balance is of type money. Similarly, we write the attribute account holder is of type string and it is a protected attribute. This minus preceding the attribute interest rate implies that this is a interest rate is a private attribute which is of type int and whose initial value or whose default value is 7, which we specify by equal to 7. Similarly, we have another attribute called last account ID, which is again a private attribute and it is of type string. After this, we have the operations compartment. We have this operation add interest which is a private operation, and we can also specify the signature of the operation. The signature of the operation consists of the attributes, and maybe along with the attributes we also supply the type of the attributes, and we may also supply the type of the return value. In this case, the operation add interest takes a parameter of type date, which we denote as add interest d colon date. Then we have another operation which is a public operation. Plus indicates that the operation is public. Then we have a protected operation set overdraft level. And we have another public operation get balance. Other than these three compartments, we can also add some other compartments to this object. For example, we may have we add another compartment to specify the exceptions of this class. So we have an access violation exception which is signaled in this class. And we may have yet other compartments. For example, we can have a compartment for specifying the responsibilities of the class. So the responsibility of the class consists of a natural language string. For example, we say that the responsibility is to keep track of the balance. Now, let us have a look at the syntax of these things a little more formally. Visibility is of three types. Plus denotes that this is a public attribute. Minus denotes that it is a private attribute. And hash denotes that this is a protected attribute. Now, let us look at the attribute syntax. So, attribute syntax, we may start with the visibility. Visibility is optional, followed by a compulsory part, which is the name of the attribute, followed by the multiplicity of the attribute, which is optional, followed optionally by the type of the attribute, which is denoted as colon followed by type name, followed optionally by equal to followed by the initial value of the attribute, followed optionally by a property string within curly braces. And this property string can consist of these words: changeable, add only, or frozen. Now, let's look at operation syntax, syntax of operations. Again, we can have visibility, which is optional, followed by name, which is compulsory, followed optionally by the signature of the operation. The signature is denoted as, within parenthesis, we have the parameter list, with or without types, followed optionally by return type following a colon, followed optionally by property string within curly braces. And in this case, property string may be live, if this class forms a diff, is query, sequential, guarded, or concurrent. Now let us look at, we can also, if there are too many operations or attributes, we can organize the attributes or operations. For example, let us look at this class Q, and let us look at the operations on Q. We can group the operations on Q into different classes. First, the constructor operations. Then we can have the processing operations. For example, add, then remove, and other operations which we denote by ellipses. And then we can have query operations. For example, is empty, is full, is ready, and so on. Right. Followed by the responsibilities of the queue, if any. For example, the responsibility of this class may be to maintain a priority queue of the processes. To maintain a priority queue of the processes. Now, if we have too many attributes and operations without cluttering them up, there are two things that we can do. First of all, we can hide some of the non-important attributes or operations. That is, we can elide a class. Elide a class, and we do not show all attributes or operations. So don't show all attributes, don't show all operations. Secondly, to organize a long list of attributes or operations, we can prefix each group with a description category. Prefix each group of attributes or each group of operations with a description category using stereotypes. If you, for example, when you look at this word constructor that we have written here, you see that the constructor is within this sort of symbol. Then we have process. We have given these names which are specific to this particular object. And these things are known as stereotypes. So we will see that stereotypes is part of the extension mechanism of UML. And also associated with an object, we can write the responsibility in another box at the bottom of the object, and responsibilities specify a responsibility is a contract or an obligation of a class. Societies of classes form collaborations which can be viewed with a object diagram. Now let us have a look at some of the common modeling techniques. So classes are the abstractions of the model, and we have already said that the classes are drawn either from the problem domain or from the technology which we are using to implement a solution to the problem. Problem domain to which we want to find a solution, or from the technology we are using. For example, a Q class comes from the technology that we are using to implement the solution. So we can follow some steps to model the vocabulary of the system. To model the vocabulary of the system, you must first identify those things that users or and implementers use to describe the problem or the solution. Secondly, for each abstraction, identify a set of responsibilities and then make sure that each class is crisply defined. And between the classes, there is a good balance of responsibilities. Thirdly, provide the attributes and operations that are needed to carry out these responsibilities Now, let us look at the set of objects that we will require to model a retail system. So, we have a retail system. Let's identify some of the objects. The one object is the warehouse. Then we have the product. The product has some attributes, for example, ID, name, price, location. Then we have the object called shipment, which has some attributes and operations, and the responsibility of this object is to maintain information regarding the product shipped. Maintain info about shipped product. So we have 3 classes so far. The other classes are invoice, then we have an order, the order has these attributes: item and quantity. Then we have the customer, we have the object customer, and the attributes for the customer are name, address, telephone number. We have an object called the transaction, and the operations are commit, rollback, etc. So these are the objects that we have designed for a retail system. Later we also have to find the relationships between these objects. Next, we will have to use packages to model clusters of classes. That are conceptually and semantically related. If we have too many classes, we will break it up into such clusters. We cluster classes that are conceptually and semantically related. Then we also have to model the distribution of responsibilities, in the system. See that the classes are crisply defined and the responsibilities are balanced between the classes, so that none of the classes are either too small or too big. So we will here, and in the next class we will take up relationships. Thank you.